Hello and welcome everyone to today's video. Today we will be talking about the level 2 algebra exam that students have sat last Tuesday. So we're going to go through all of the questions so you can check the solutions, see how you have done, and also to justify if this was a really hard exam or if it was not. If you're using this video in future to prepare, make sure you're using your time. Pause the video before we actually get to the solution and attempt the question yourself, just to make sure that you get the learning part of doing these questions. All right. Also make sure that you are following me on my socials, subscribe to the channel, and make sure that you like and comment, just to make sure that more people get a chance to learn together with us. All right, so let's jump right in. Our first question is going to be, write x squared plus 8x minus 5 in the form x plus p in brackets squared minus q. Now this question has two ways to solve them, and the first one is by using completion of the square. So let's have a look how we do this. First, we want to use a special way of factorizing to make it a perfect square, so something in brackets squared. And we have our special formula a plus b in brackets squared that helps us achieve this. So completing the square, if you know the algorithm, just follow the steps. We take the number that is in front of the middle term, the x term, which is 8 in this case, we half it, and we add half of that squared, and we take away half of that number squared. So here we can see 8 over 2 squared and 8 over 2 squared is added and subtracted. This is a little bit of a trick, because what we're actually doing is we're adding 0. We're not changing anything. We're making it look different, but we're not changing the actual numbers. Now if we simplify these, 8 over 2 squared, we can do 4 squared. And now the first part, this is where the magic happens. We have the x squared plus 8x plus 4 squared. They form a perfect square, so they are going to be creating our brackets with the squared on the outside. So here we have x plus 4 all squared. Now minus 4 squared and the constant minus 5 at the end still remain the same. So we can now go ahead and simplify those and put them together to find what the answer is. Now our final answer is going to be x plus 4 all squared minus 21. This is the vertex form of our quadratic and the final answer that they want here. Here we have p is equal to 4 and q is equal to 21. Not minus 21, be careful, because in the question it is already saying minus q. Let's have a look at the alternative method. If you don't know how to complete the square, I highly recommend to check out a video. I'll post it in the bottom so you can learn how to use the completion of the square method. However, if you didn't know how to do it, let's have a look at an alternative method. Now the question is the same, but this time we're actually going to start with what we want. We're going to start with x plus p all squared minus q. And what we want to do is we want to expand here and write this form in standard form. So if we expand, remember, use the FOIL method, and don't forget to write the two brackets next to each other, because we want to make sure that we don't forget the middle term. Now pause the video and make sure that you follow through with the factorizing and expanding parts. So here, if we expand, we get x squared plus px, another px, and plus p squared. And of course, don't forget the minus q at the end. Putting like terms together, well, we had two px terms. They are together. And we also have at the end the number p squared minus q. That one doesn't have any x. So that is going to be our constant term. Now I've already marked them in color, because this would be the numbers a, b, and c in front of the variables if this was in standard form. And all we do now is we write the numbers that we want underneath and make sure we match them. So So we want this actually to be the same as x squared plus 8x minus 5. Here we can see that number in front of the x squared, which is 1, is already matching. There is nothing we need to do. That's the yellow part. For the blue part, in order for both of those to be the same, which is what we want, we need the blue part, 2p, to be the same as the 8 in the blue. So we can form two equations here. One for the blue parts being the same, and one, of course, for the green parts to be the same, because the constant term at the end also has to match. So 2p has to be the same as 8. This is a simple equation that we can solve by dividing both sides by 2. So we get p as 4. And if you remember from the question before, well, that is exactly what we had as well. For the second part, our equation is p squared minus q is equal to minus 5. Now we have two variables, but we can already substitute in for p because we found that in the blue part. So we're going to replace p with 4 and then solve our linear equation. 4 squared gives us 16. Then we're going to move the 16 over to the other side by doing the opposite. Well, 16 is just there. It's added and subtracted to the terms. So it has a plus in front that is invisible. We don't write a plus in front of positive numbers. But to move it to the other side, we do minus 16. So then on the right-hand side over here, we get minus 21 is equal to minus q. Remember, when you move the 16 to the other side, don't forget the minus in front of the q. Well, now both numbers are negative. We can times by -1 or just make both sides positive, whichever you prefer. And we get q is 21, just like before. The second achieved question for this paper is find the discriminant of the quadratic equation 3x squared plus 2 is equal to 5x. So let's have a look. What can we do? Well, we have a formula for the discriminant, which is actually in your formula sheet as well. So the important part is we need to meet the requirements for that formula. We need to write this in standard form. So that means we need to write it equal to 0. We need to bring the 5x over to the other side by doing minus 5x. And now we can see something x squared plus something x plus a number is 0. So now we match our coefficients from the quadratic formula. A will be 3, minus 5 is b, and c is 2. Make sure you don't forget the negative in front of the 5, which is a very common mistake. Always check when you're checking for numbers, is there a sign in front that I need to worry about? Now lastly, we're going to have the discriminant is equal to b squared minus 4ac. And I purposefully wrote the little triangle in front because that is how you can see that this is the discriminant in your formula sheet. All we need to do now is substitute our values a, b, and c into this formula. So let's do that right now. Remember, when you're substituting in values, I highly recommend putting brackets around them every time you substitute them in. Here we have the minus 5 all squared. The brackets are important because the squared is only for b, but b is the whole thing. It is minus 5. Either way, you can just put this in the calculator, or you can do your computations by yourself, and you'll find that the discriminant is equal to 1. This is the second achieved question for question 1. Wonderful. Let's move on to the next question. Write as a single fraction. Well, here what can we see? We see 3 different fractions. Different denominator. And if you think about how do we add or subtract fractions? If you're stuck, always go back to the basics. So think about having 2 fractions, 1 over 2 plus 1 over 3. How would you add them? Remember, we need to have the same denominator for the fractions. So this is going to be our first indicator on what to do. Here, if we inspect the bottoms, we need to make sure that they all have the same. So I can see that one of them has a factor of 3, One of them has a t squared. So all in all, if I multiply by things, 3t squared is what I can get from all three of the fractions. So let's do them one by one. Let's say 1 over t. What do I need to multiply the top and the bottom by so that the bottom matches 3t squared? Well, we definitely have to multiply by 3, and the t needs to be multiplied by itself to get to t squared. So we need to multiply 1 over t by 3t over 3t. If we do this, we get the equation in the blue above. We're going to do the same thing for the second part. And here, the people who wrote this exam were very friendly, very nice to you, because they actually put t minus 5 in brackets. They didn't have to do that because it is generally understood that if you have a fraction, that both the numerator and the denominator have invisible brackets around them. So when you're now using equivalent fractions to multiply by top and bottom by 3, because remember we want the common denominator to be 3t squared. This way we don't forget to use expanding in the numerator. In the denominator, this is not an issue because we have 3t squared and it's a product. So for the numerator, we can expand 3 times t is 3t and 3 times negative 5 is negative 15. So we have it up at the top. So let's move on to the last one. 1 over 3t. We have to multiply the top and bottom by t so that we get the same denominator. All right, let's put them all together. We're just going to replace each fraction with what we've got from above in our simplified form. This is what you can see on the side. And now remember, how do we add or subtract fractions when we have the same denominator? We just keep the bottom the same and we change the numerator and put them all together. They're added or subtracted. So here I have put all the numerators together. Just be careful, at the end we have a minus t. This comes from the second fraction being subtracted. It often happens to forget a negative like this. Now all we need to do is simplify this fraction. So we add the t's together, 3t, another 3t, and minus t. That's 5t, and minus 15 still remains in our equation. This is our final answer for this question. Now, we can check if we need to simplify this, but there's no common factor for the numerator and the denominator. Okay, next question. So here we have a cubic polynomial is given by f of x is equal to 3x squared plus ax squared plus bx plus c. We have a, b, and c are constants, so there can be any values. And the graph of the polynomial has 3 roots. And cut the x-axis at -2, 1/3, and 4. Using your knowledge of the roots, find the value of the constants. So let's have a look. Remember that roots are x-intercepts. So when we solve equations, we usually want to make it equal to 0 and then solve for x, which is your roots or your solutions that you find when you find x equals. However, now they have already given you the answer and they want you to work backwards to the equation. Remember, when you factorize, set equals 0, factorize each bracket, you make it equal to 0. So for example, x minus 1, if this is in your brackets, you write x is equal to 1 because 1 minus 1 is 0. So we're reversing the signs. Now if we're doing the steps backwards, we need to do exactly that. So let's give that a go. We have our solutions given above. In order to write what we have in brackets, all the factors, we need to just switch the sign around because we're talking about x values. So here are the 3 factors. We have x plus 2, x minus 1/3, and x minus 1/4. Now, in order to expand this, we want whole numbers. We don't want fractions. So at the top, we don't really want to have minus a third. So how can we get rid of this? You actually encounter the same situation when you're using the AC method in factorizing. When you're factorizing with a number in front of the x squared that's not 1. So if you remember how to do that, that just moves in front of the x. So we get 3x minus 1 as a factor. Let's put them all together. We have those three, and we know that this is the factorized form. So if we expand everything, we should get back to all the way at the top to our standard form. We have three separate brackets, so we need to do them one by one, leaving one out for later. So first, give this a go, expand these two brackets, and remember to keep them in brackets. Now, once you've expanded these, you need to make sure that you simplify first to make the calculations easier. So we can see minus x and 6x are common terms, like terms, so we put them together to 6 minus 1 is 5x. And now again, we expand again. You could have started with the larger brackets and connected that with each of the other bracket, or you can start from the other one, it doesn't matter. For practice, you could try to do it the other way and see if you get the same answer as me. All right, I assume at this point you know how to do the expanding. Follow all of the parts in the FOIL method, all of the lines, and multiply them together. We get a lot of terms. Again, we need to simplify these. So I've color-coded them so you can see where they're coming from, which multiplication. So let's put them all together. There's only one part that has an x cubed, so that has 3x cubed. If you put the squared parts together, we get minus 7x squared, and the x's together, you get minus 22. And don't forget the number at the end that doesn't have the x. Now we're going to use the same method that we used in our first question, where we're comparing the numbers in front of the x squared, x cubed. Yeah. So we wanted to get 3x cubed plus ax squared plus bx plus c. And we know from our factors and from our roots that this here is our equation in standard form. So now we just need to write down what these constants are, and we're done. Just be very careful. Remember to use the negative. If we have a minus 7x squared, then a would be minus 7. I would say this is the first merit question of the paper. We don't know yet about the marking schedule because at the time of making this video, we have not actually got the NCEA marking schedule out. The exam was just last week. So let's have a look. This question looks very difficult. We have a lot going on: fraction, multiplying things, expanding things, powers with fractions. But remember, level 2 is all about exponents, knowing your laws about exponents. So this seems like a very complicated question. It is a little bit tedious, but however, if you remember just one of the rules that they gave you, you will have a much easier time. So remember that if we have the same base and we're multiplying terms, so at the top we have x to the power of a times x to the power of b, then we add the powers. So we have x to the power of a plus b. Now, in order to do this question and to start with it, this is all we're going to be applying. Well, let's handle maybe the numerator first. In the numerator, we have two big brackets. Again, we use our FOIL method to expand these brackets. Every element in the first bracket is multiplied by every element in the second. Now, I have made sure that this is color-coded so that you can follow where we're going. For example, the green is x to the power of 3 over 2 times x to the power of half. So I've written them all out so you can see where these are coming from. And again, make sure you get your negatives and your positives right. Once we're here, all we're going to do is we're going to apply the rule from above, and we're going to add the exponents because all of these are multiplied together. And let me scooch over a little bit so we have some more space. The first one, we have 3 over 2 plus half is 4 over 2. You can just do this in the calculator if you want. It will be simplified to 2. And if we do this for all of them, we get in simplified form this. Now, for the middle terms, remember, power of 1, we normally don't write, so we just have x. And at the end, anything to the power of 0 is 1, no matter what the base is. So we get to this equation here, and minus x and plus x, if you add them together, well, this is just 0. So we end up with just x squared minus 1 for that complicated looking numerator. So let's put that over in the top. We will need that later, on this side. And let's actually look at the denominator. The denominator has something squared. Now, don't make the mistake of just squaring the first part and squaring the second part in the fraction. I see this all the time. Make sure that you remember when you're expanding something with a squared to write them next to each other, because there's actually 4 terms that we're going to have. And if you forget to do so, you're likely to forget the middle terms. So again, just like before, we've expanded using colors to make sure that all of these are visible to you to know where they're coming from. I encourage you right now to pause the video and make sure that each of these expanding parts, that you're able to do them and follow through where they come from. And again, we're going to use the rule from above, and we're just going to add our powers, and we're going to see what happens. Now, if you want to, you can do it in the calculator or simplify in your head. That's perfectly fine. Then we get x to the power of 3 minus x squared again plus x. And we can put together the x squared terms. Then we end up with x cubed minus 2x squared plus x as the simplified form. Now, we have simplified the numerator. We've simplified the denominator. So I've got them at the top if you need them. Let's put them together and try and solve this question. Okay, so I've written this as a fraction with a numerator and the denominator, and this should be a question that you should be very comfortable answering, because there will be multiple of these questions, not just in this paper, but in many past papers. If we see a fraction and we have sums or things added or minused at the top and the bottom, then the only way to simplify them is to factorize the top and the bottom. Remember, we can't cross out the x squareds here, because in order for us to cross something out, we need to ensure that everything in the top and the bottom is multiplied. We're not allowed to have anything added or subtracted. So, how do we simplify this? Let's do this. Factorizing top and factorizing bottom. So, the top is a difference of squares. You should recognize there's no x term, so I assume by now that for this question, if you get this far, that you are very comfortable factorizing. Here, we're looking just for something with the same roots, so plus 1 and minus 1, and in order to get to x squared, we need x. So we have x plus 1 times x minus 1. If you want to use your normal method of finding the factors of 1, which is just 1 times 1, and you need 1 positive, 1 negative to make the middle number 0. That works as well. Now for the denominator, we see that every term has an x, so we can factor out the x. We don't know how to factorize cubics at this point. So now we can factor out the denominator again, because we have x squared minus 2x plus 1, and we can factor this into x plus 1 and x minus 1 and x minus 1 again. Only now do we see that both the numerator and the denominator have the same factor. And now, because we factorized it, everything is multiplied. Now we can cross out some of those factors, and we're left with exactly what the question is asking us to show. Now, I'm pretty sure this is going to be the equation, the first equation on the paper, because we need to use multiple factorizing steps. We need to use the multiplying terms rule as we see all the way above. But this question is a very good question to show that all you need to do is follow steps through one by one, following rules that we've learned in class. Now, don't get intimidated by some of these dangerous, difficultly looking questions. All right, that is all to this question. Yes, we're moving on to the second question of the paper. So here we want to solve 3x minus 14 is 5 over x. Well, let's copy it and let's go from there. Remember, solving means we want x equals. Well, every time when we solve, I always make sure that everyone checks what we actually have. We have something in the denominator with an x. That is not very good. We don't want something in the denominator or fractions in general with x's in it, so let's get rid of that. In order to get rid of the x in the denominator, we have to multiply by x. That's okay, because multiplying by 0 is not allowed here, because 5 over x is not allowed. So if we're multiplying by x on both sides, then we get 3x minus 14, all multiplied by x. Remember to put brackets here because you are multiplying the whole side by x, and in order to show it's the whole side, we can use brackets. Now we need to expand. You can use the FOIL method as before. X times 3x becomes 3x squared, and x times negative 14 is negative 14x. Again, just be careful with the negatives. This is the most common part that students get wrong. Now here we notice that we have a quadratic, and in order to solve a quadratic, we always need to make equals 0. From here, we can do multiple steps. You can use the quadratic formula to substitute in your values a, b, and c to solve for x. That is fine. You're also welcome to use your calculator, use the equation function polynomials degree 2 to enter all your details to get the answer from here. If you're using the factorizing method, make sure that you recognize that there's a number in front of the x squared. So that means we have to multiply that number 3 times the constant, which is minus 5. Now here we get factors 1 and 15 and 3 and 5. And the numbers that make together negative 14 are negative 15 and positive 1. So we use those. Now, because we're factorizing with a number in front of the x squared term, don't forget you need to then again divide by those. If we simplify these, then we have x plus 1 over 3 and x minus 5. X minus 5 is okay because that's the whole number. But just as discussed before, x plus 1 over 3, we don't want to have these fractions when we factorize. So the 3 moves in front of the x. Now, if you get to this part where you have your factorized form equals 0, now we can set each of the brackets equal to 0. So we get 3x plus 1 is 0, and we can solve that for x by moving the 1 on the other side by doing minus 1, and then dividing by 3 to get x as negative a third. On the other hand, we need to do the same for x minus 5, set it equal to 0, and move the 5 over, or if you want to, just switch the sign. Now these are the two answers to our solution, and both of them will work because remember the only problem that we had is that it says 5 divided by x. The only way that would cause problems is if we would have 0 for x, but we do not, so all of those are perfectly fine. Awesome. This will be another achieved question. Now, this simplifying question is very much the same as all the past papers of the last few years, with one exception, and I'm sure you can tell. The square root on top of the numerator makes this again look quite disgusting. Well, with these questions, remember, we have a fraction, we have terms added and subtracted, we cannot cancel them out. The only way that we could simplify them is if we factorize and then cross out the same terms. Let's do that. Let's factorize. Again, we want to factorize the numerator and the denominator, so let's start with the numerator. Let's copy it. Well, for someone who wants to factorize here, we need to have a look at the 9 and the 25. You can use the AC method, you can use the factorizing method for numbers in front of the x squared. If you're not familiar with these, I'll put those in the description on the second link so you know how to do all your factorizing very well. Now, if we look at this, we have a 9 and we have a 25. So if you think about numbers a little bit, we need 3 squared to make 9. We need 5 squared to make 25. These are both prime numbers, so things are working nicely together. So if you see this, then you can get to the part that this factorized is 3x plus 5 times 3x plus 5. Now, if you need help, remember to check out all those factorizing videos where I go into detail on how to factor each different type of polynomial of degree 2. So, now if you recognize now, here both of those brackets are exactly the same, so they're multiplied by each other. Well, what does that mean? 4 times 4, well, that means it's 4 squared. So here we have just the brackets squared. And now this is where the question becomes a little bit harder, much harder than in previous papers. This is something that is very difficult, but you should keep in mind. If whatever is in the brackets here, if we square it, that makes it positive. So even negative numbers squared will become positive. And if we then take the square root, it can only give you a positive value because that's what the square root function does. It is not able to give you the negatives. It's not defined for negative numbers. So even though this all works well, we need to consider a rule that you might as well remember now. If you ever see the square root of x squared, even though they're opposites of each other, you need to be careful when you do this operation because of this negative sign that might be lost. It is actually true that the square root of x squared is the absolute value of x. And if you haven't seen this, this is in your graph paper in level 2, so you should know what the absolute value function does. In the end, it makes everything positive, so we get positive values, but let's have a look what we get if we get this as an answer. Let's keep that for a little bit later, and let's put this all over at the top, and let's do the denominator. Now the denominator is probably, it might give you an achieved if you just factorize either the numerator or the denominator. It depends on the marking schedule. You might require both. But if you look at the denominator, we just have common terms in terms of the x. There's nothing else we can factor here. So we just factor out an x. Now, this was pretty easy. However, let's put them both together and have a look. Here at the bottom, we notice that we had 5 plus 3x. They switched the order. But in the top, we had 3x plus 5. Just to make sure we know what we're doing when we're crossing things out, I have switched these around, which is okay when we're doing plus. So they are actually exactly the same thing. Let's put them together. Oh, there's an equal sign over there. So let's put them together and see what we get. So right at the top here, we get the absolute value of x plus 5 divided by x times 3x plus 5. Now, this solution here is probably going to be what gives you a grade, the grade here. Not remembering the absolute value here and just crossing out the top and the bottom, I would say should give you a merit here, but we shall see about that in the marking schedule. What do we get? If they cancel out, we just get 1 over x. But let's have a look. How would we do this properly if we actually think about the absolute value. So if we talk about the absolute value in the numerator, then we have to think about what the absolute value actually does. This is going to make things positive for, well, everything. But the way that the absolute value function is defined is that if you want to get rid of the absolute value, you need to know for which value the number inside is negative and when is it positive. So here we can see the inside of the absolute value function is positive as long as x is greater than negative 5 over 3. And all we did here is solved just like we would in a linear equation, just with the greater than 0 sign, because greater than 0 is positive. Now we do the same thing for negative at the bottom, and I've just given you the answer. X is less than negative 5 over 3. Now, what does that actually do? This means we have two different cases. The absolute value always needs to be considered for cases. So if x is less than negative 5 over 3, remember that makes the inside negative. If we go back real quick, so the inside is going to be negative, correct? So it changes the sign for the inside part. So what we do is we actually change the absolute value part into brackets, and then we put a negative in front. At the bottom, we don't have an absolute value sign. We still have the normal brackets, so crossing them out will give us negative 1 over x. But on the other hand, for our other case, we don't get that negative in the numerator because of that reason, because of how the absolute value function is defined and how we handle cases. Here we get 1 over x. So the simplified answer actually depends on what the x value is. So depending on the x value, it's either this or this as the simplified form. Now, I'm not sure if this is going to be part of the marking schedule. We will see this in January, and I will make sure to comment below for the people who are using this as practice for future. But this should have been known for the person who wrote this exam that square roots are dangerous. Perhaps this will give you the E7 or the E8 mark. Okay, find the value of x for which the equation, as you can see at the top, has numerical roots equal but opposite signs. So that means, for example, 2 and negative 2. So first of all, let's just think about what does it mean to have numerical equal roots. Well, this could be that the roots could be -1 and 1, or 2 and negative 2. So with other words, we know that this whole equation is going to be symmetrical around the y-axis. We have the middle, and on each part, the roots are in the same distance from 0. The only important part here that's really important is that we remember that if we have the same number for the roots just with a change of the sign, is that the value in between, in the middle term of the expanded form, is going to be 0. But we will talk about that more in a little bit. If you don't understand what the question wants here, I would still highly encourage you to start with a fraction and just do what you would normally do with something that has fractions, which is just start cross-multiplying each side to start solving. We can also think of two roots. We can talk about the discriminant being greater than 0, so this might be something that we need later on. We're not sure if we need this at this point, so we're just going to mention it for now, and we're going to continue to go through the question until we get an answer. And as I said, even if you don't understand what the green part is doing, you should at least start simplifying to get some of those achieved marks that are expanding and factorizing. So what do we do here? We have two fractions. We don't want fractions, so we need to get rid of the denominator, so we can cross multiply here. So when we cross multiply this, make sure that you understand that this is what we'll get. One side is x squared minus 2, and we cross multiply it by k plus 1. Make sure both have brackets around it, because I said this before in the second achieve question, that if we have fractions, it is understood that there's brackets around the numerator and the denominator, but we don't write them. So here, for the higher marks, you need to recognize that those are there. Now, when you look at the errors here where I'm expanding, I'm using a little bit of a different strategy when I'm expanding. You're more than welcome to do the full FOIL method and expand everything term by term. The reason why I didn't here is because I noticed that k plus 1 and k minus 1 are just two numbers. I don't know what they are, but they're just numbers. And if I had just a number in front of a bracket, I would just multiply that number with each term. Either way, if you want to have some practice in expanding, you should expand this and see if you get to the same answer. Now, I've color-coded them so you can see what I'm expanding and where I'm getting from. Now, we see here at the very beginning, we have a term with an x squared, and we have terms with an x, and then again on the other side with an x, and one at the end with no x. So how do we deal with that? Remember, we need to put all the terms together that have the same term. So here, I will be moving over the constant coefficient at the end, and the x value, the k minus 1 times 4x in the green. And I'm going to make it equal to 0, because remember, that is our strategy if we're solving. And here you can see now why it has been a good idea to keep the k plus 1 in brackets. Expanding would have meant that I would have had to put all of those coefficients together, but here I only have two terms with an x. Now I can factor out the x to find the coefficient which goes in front of the x. Just to make this a little bit easier, I have given you here the fully expanded version, so you can practice. If you did practice earlier on, this will be where you get if you do go from straight here. So looking at this one here, we have k plus 1. That is all the numbers that are in front of the x squareds. Well, there was only one x squared term here. If we look at the x terms over here, we can get to the blue part. We have minus 4k, we have minus 2k, and we have a minus 2. So we end up altogether with 2 minus 6x. 2 minus 6k. Now, when we look at this question, we have a plus k minus 1 right at the end. This is the one that doesn't have any x values, no x term. So if we now look at this question, this is in our standard form, ax squared plus bx plus c. Now, we need to understand what the question actually wanted from us for using numerically identical roots. I've copied the question that we've got from before over here, and what we want is we want this middle term to actually be 0, because we want to create this perfect square. Well, in this case, how do we get 0? The only way to get 0 is if 2 minus 6k is equal to 0. So if we solve this, we get k is equal to 1/3. This is actually the answer. We want to find the value of k such that the condition for the numerically equal opposite signs for the roots is still intact. Well, we could test if this is correct. So this is a little exercise for you to check and make sure. This is not required in the marking schedule, or it will not be, because it isn't asking you to find it. You've got it already, but it would be good to check and make sure we haven't made a mistake. If we substitute in k at the top and simplify, go through the steps and make sure that you know, here we can just move the 2 over, and then we get 4x squared is a number. We can divide both sides by 4. Then we have x squared is half. And then we take the square root on both sides, giving us positive and negative half. And if you simplify them or you use the calculator, you will get root 2 over 2 and negative root 2 over 2. These two, you can check in the calculator, are actually exactly the same numbers. So make sure that you check that out. You will learn in level 3 in year 13 calculus in the complex number part why this is the case. All right, so let us go through the next question. So here we have the logo for an IT company, Doctor of Data, shown in the diagram on the right. The green background of the logos is the shape of a rectangle with length x. We can see that in the picture at the bottom. And we have the letters DOC are formed using semicircles for both D's and the circle for the O's. The one O, I guess. Each has the same radius. The area of a circle is given as a formula pi r squared. And we have been given the question, find an expression in terms of x for the area of the circle in the middle of the logo. So if you have a look at the picture that I've drawn above, we have just got our circles with radius r. So we just apply our formula. So let's have a look, how could we find r? Well, we've given the length of the whole rectangle is x. So all we need to do now is make sure that we divide it into 4, because we can see in the picture we have 4 times the radius. If 4r is the same as x, then what does that mean? We can divide here both sides by 4 to get an equation for the radius in terms of x, which is x over 4. Now the area has been given to us as a formula. We just substitute in our r, which is x over 4. And as I said before, it's really good to always substitute using brackets, because now we know the squared goes to the numerator and it goes to the denominator, leaving us with pi over 16 x squared, and this should be another achieved question. Now, in order to get a higher mark here, let's have a look what we need to do. If the green background has an area of 10 centimeters squared, find the length of the rectangle. So we need to have a look, well, the green area in the background, how could we possibly get that area? And it looks like what we can do is we can find the area of the rectangle and then subtract the circles, the circle parts. Well, we can see it looks like there's 2 areas that are a circle if we put the half circles, the semicircles together. So let's start with those. What is the area of those 2 circles? Well, we have already calculated that from before, but we just need to multiply it by 2, so that's pi over 8 times x squared. Now let's find the area of the rectangle. Well, we already have one side, which is x, but how do we find the other side? We know that one side is x, which is 4 times the radius, and the other side is 2 times the radius, so that's half of x, half of the length. If we multiply them together, remember base times height, then we get x squared over 2 for the area of the rectangle. Now we just need to take the area of the rectangle, the bigger object, and take away the area of the 2 circles. Now, if we do this calculation, we see they're both x squared terms, so we can factor out the x squared term. Let's do that all together here because it's a little bit longer. So we can factor out the x squared term, and at the same time we can set the green area, what this equation equals to, just because that was the information that was given to us. Now, in order to find x squared here, or x, we need to divide by everything that's in brackets. You can either do this whole in the calculator, 10 divided by everything that's in the brackets, or what we can do is we can first put them on the common denominator, multiply the first fraction by 4 over 4, and then putting them on the same denominator 8. 4 minus pi is the numerator. Now we can times by 8, and we can divide by the numerator. Now we've got a value for our x squared. Now how do we find x? Well, we have to take the square root. But remember, we do the positive and the negative of the square root. Well, where does that come from? Remember here, we're going to have x squared square rooted. So we have a positive and we have a negative option because of the absolute value that we had in the previous example. This is actually where the positive and negative square root comes from when we're solving. Now, these values you can just put in the calculator as they are, and you get two answers. X is 9.6538 or negative the same number. But remember, what does x stand for? It was the length of the rectangle. So here we need to say that it cannot be negative, so it has to be the positive version of this. Now, for the next question, question 3, we are going to have our first achieved question by just using one of the rules that you've been learning about logs. I've blended in at the top. We've got the log of a base of some value a is c. This statement is actually equivalent. It's exactly the same statement as over in the other corner, b to the power of c. So the base to the power of the opposite is equal to what is in the brackets. So let's apply this to our question here. Well, the base here is 5, the opposite part is x, and what's in brackets is the 625 part. So if we just apply that rule, then we get 5 to the power of x is 625. Now we see that x is in the exponent. That's hard to solve for, so we need to use log on both sides to bring the exponent out. So we apply the natural log on both sides. By the way, it doesn't have to be the natural log, it could be any log. I'm used to using natural log, so I'll do that here. Now if I do the natural log on both sides, then I can use another log property that means that the exponent, which is x, can be brought out to the front by multiplying. So we get x times the natural log of 5. Well, natural log of 5 is just a number, so we can divide by that, and then we get to x is equal to the natural log of 625 divided by the natural log of 5. If you put that in the calculator, you'll see that this is 4. Now, sometimes if these answers are perfect numbers, nice integer values, then we can actually do this by hand by checking which power could possibly work. If you're stuck in between and this doesn't work, well, then you need to make sure that you know the log on both sides rule. For the next part, we need to solve 9 to the power of 2x plus 3 is 1 over 27 to the power of x. Well, the first thing that I see here is again x is in the power. So we need to really have a look, what could we do? Well, the rules that we know about powers is that the bases have to be the same, and that doesn't seem to be the case here. So we need to check, can we make the bases the same? And here I've highlighted 9 and 27, and maybe these ring a bell because these are some of the numbers you should have been practicing for this exam. 9 and 27 can both be represented with a base of 3. So 9 is 3 squared and 27 is 3 to the power of 3. So now in order to change these, I'm just going to replace them and put them into the other equation and see what happens. Now remember, it is important that when we substitute or replace values that we put brackets around it, because now we can use our different rule in the first part. We have 3 squared all to the power of 2x plus 3. Now if we have something to the power of power again, that means we multiply the powers. Now here be careful, what should you be remembering when you multiply the powers? Well, there's again brackets. 2 times the bigger power is 2 times in brackets 2x plus 3. On the other hand, I replaced the 27 with 3 to the power of 3. But I didn't like that this was in the denominator. Remember, we can bring something out of the denominator or switch in a fraction if we do a negative power. So here, having a negative power means we bring the 3x cubed part out of the fraction into the numerator, but we have to make it a negative power. And again, we have the rule 3 to the power of negative 3 to another power. So we multiply those two powers. While we're doing that, I expanded the other side, which becomes 4x plus 6. And now we're at a point where both of the bases are the same. Now what we can do here is, because the bases are the same on both sides, well, the only way that both sides are actually the same numbers is if the exponents are the same. The bases are already the same, so we just need to match the exponents. So what we actually just need to solve here is that the powers on both sides are the same. Well, here we need to do a simple calculation, bringing the 3x to the other side by doing plus 3x and moving the 6 to the other side by minus 6. And then we can divide by 7, which will give us negative 6 over 7 as the answer for the solution. Now we have another log question. We have if log b of x is 2 and log 3b of y is 2, then write y in terms of x. Now if you're not sure what to do here, you should remember every time we see logs, we should have a look at what our rules are. And again, we're going to use the same rule that we have used before to write these log base b or log base 3b in a different way. Pause the video now and see if you can rewrite these correctly. So the first part, we have b as the base, the power is the opposite side, and what's in brackets, well, that's the x part, that is on the other side. The same goes for the second part, but remember the base 3b, it's all in brackets because that is the whole part in the log, in the base, that we move over. So it's 3b to the power of the opposite number equal to what is in brackets, or the y. And now we have two statements, and we can simplify the one for y, giving us 3 squared is 9, b squared is b squared. And now what we can see x is b squared, so we can just replace b squared with an x, giving us y is equal to 9x. That is already the answer to the question. I think that would be an achieved. So let's move on to the next question. Here we need to consider the equation 3x squared minus 4xk plus k squared is equal to 0, where k is a constant. Using the quadratics formula, find the fully simplified solution to the quadratic equation in terms of x. Well, this question is just asking us to use the quadratics formula. So you can go to the formula sheet and make sure that you know what this one is. Now I've color coded these so we can see what we get. The 3 is the A. Remember the negative minus 4k is in green. That is our b value, and k squared is our c value. So if we now put all of these together and substitute in, we get this big term for our roots. Now we just need to do some simplifications here. So first of all, the first thing that I see is there's a minus 4k. Negative and negative makes positive. The other thing that I see is that the bottom is 2 times 3 is 6. And I like splitting this up very early, which means I'm going to split the 4k divided by 6. And then I have to still divide by 6 for the fractional part, for the square root part. So here, instead of writing divided by 6, I have just written times 1/6 in front, which is the same thing, just to ease the calculations. Now, for the inside function, we have negative 4k squared, negative and negative becomes positive, so we have 16k squared, and the other term is going to be 4 times 3k squared, where the negative is 12k squared. Now what else can we do here? Inside the third, underneath the square root one, we can simplify because we both have k squared terms. So let's put them together. 2 over 3k plus minus the 1 over 6 root of 4x squared. Well, again, we can simplify the square root because 4 is a perfect square. That will become 2. K squared is going to become k, and we don't have to worry about the plus minus here. Why not? K is a constant. It doesn't matter if it's positive or negative. It is just any number. It will work out itself. So if we put these together here, we simplify. The 1 over 6 times 2 becomes 1 over 3. So our first solution we have to write down is this expression here with a plus in the middle. Well, that becomes 2 over 3k plus 1 over 3k is k. And the other one is when we have a negative, which becomes 1 over 3k. Both answers will be required here for a mark. Okay, next question. The level of sound, which is the intensity, is measured on a logarithmic scale using a unit called decibel. The formula for the decibel level D is given by D is equal to 10 times log base 10 of P divided by P0, where P is the intensity of the sound and P0 is the weakest sound that a human here can hear. So a cooling fan has a decibel level of 38 decibels and a heat pump has a decibel level of 30 decibels. Show that the cooling fan sound intensity is more than 6 times that of the heat pump sound intensity. Now, what do we do here? First of all, it talks about intensity. So let's have a think. What do we have for the intensity here? Also, we note that P0 is just a number. We weren't actually given what the weakest sound level is that we can hear, but we know it's some number. So now we have D, which is our intensity. Now, D is a formula that we were given that has the intensity in it. We want to solve for this intensity. Now, what can we do here? Remember, the intensity is P. It is in our logs. We don't like P being inside our log, so we want to get rid of the logs. Well, just like before, we want to use the same equation again to rewrite the statement. But before we can apply that formula, we need to divide both sides by 10 because we have to have no number in front of the log. Now, we apply the same rule. 10 is the base, so that becomes the base. The opposite, the equal sign, becomes the power, and what's in the brackets becomes the new equal part. Yeah, just apply the same rule again that we've applied multiple times so far in this video. Now, what we actually want here is we want the intensity. So let's rewrite this in terms of P. Well, we just need to multiply by P0. So this is now our new formula for the intensity. Let's put that right up in the top because we will still need that later. Well, for the fan, it was for the fan and the pump, we were given specific information. We're told the decimal level, so the D value is known to us. So that means we can substitute that in to our formula. And here I'm using PF to show that this is the intensity F for the fan. And I'm going to do the same thing for the pump using another P, PP, for the intensity of the pump. Now, the question is now asking us to show that the cooling fan is more than 6 times as loud or as intense. So by comparing those two intensities, we can do this by dividing. How many times do we need to, do we need to multiply one of them by to get to the other? So if we divide them to get the ratio, we can substitute in, and we can see straight away both of them have a multiple of P0, which means we can cancel this out. And now all that we have left is numbers that we can put in the calculator, but just for a little exercise, what would happen if we didn't use a calculator for the start? Remember, if we're dividing, the powers are subtracted. So 3.8 minus 3. We still need to put 10 to the 0.8 in the calculator to get the value of 6.3 something. This shows us that is being more than 6 times as high for the intensity for the fan compared to the pump. All right, this is it. This was the whole paper for algebra. Please put in the comments if you thought this paper was more difficult than previous papers, and make sure that you check out the videos in the description if you struggled with some of those concepts. And I would be very happy if you could subscribe